Okay. So here we are. Shubhro, did you start your streaming, live streaming? Are you there, Shubhro? Okay, I think he has started. Anyway, so to start working with Azure DevOps, okay, we need to have an account on Azure because Azure DevOps is some subset of a tool coming from Microsoft. So unless and until we have an account on the Azure portal. Okay, so we will not be allowed to use Azure DevOps. That is one of the very important concept. I cannot have an account directly on Azure DevOps. Okay, so keeping this in mind, we have to create an account. Creating an account on Microsoft itself a project. So anyway, that is a different topic, but you just have to be very careful about creating an account because initial month you will be getting a $200, which is free. So $200 is a huge amount to spend over a month because that 1 month is the training period. That means you are getting aware of how to use the Azure portal. So this is the Azure portal. Azure portal is the Azure cloud. You have heard about Azure cloud, isn't it? Which is a competitor to AWS cloud. Oh, it is. It has logged into Azure. It has logged into Azure. So let me, because I have an account on Azure. No, both are Azure DevOps. So I will check. Yeah. So this is your portal. Like we do it on AWS. I think we have gone through AWS session some time back. So this is your Azure portal. Azure portal is nothing but the Azure cloud, the Microsoft Azure cloud. So you have a lots of services, the resources on whatever the virtual machines. If you compare virtual machines, it is nothing but Azure virtual machines, which is similar to your, what is that? Similar to in AWS? Nothing but EC2. EC2 is the virtual machine in AWS, uh, whereas your virtual machines or virtual resources are called as it is called in Azure services. I'm not discussing about the Azure cloud. I'm saying that we need to have an account on Azure. The billing will all be managed by Microsoft Azure. So Azure DevOps is one of the part of, you see, this is the Azure DevOps. So this is one part of Azure services. This is everything within a cloud like Microsoft Azure these are all your services. You can create your resources. These are all default services. There are many more services, lots of services like in AWS. Okay. I'm not going to the details of Azure because that is another cloud. We are focusing on Azure DevOps. So once you have an account on Azure, so this is my account. And this is under the default directory services. Okay. So Azure has a lot of things for security purpose. Anyway, I will go to my Azure DevOps. So coming from having an account in Azure, I will be able to create the Azure DevOps service. This is a service. Please remember, this service is mostly done or given by Azure as a CI/CD pipeline. Now, AWS does not have its own inbuilt CI/CD pipeline. Okay, that is one big advantage that Azure has over AWS. That's why Azure is becoming a bit more popular in comparison to AWS. You have one account with Azure, you will have the CI/CD pipeline coming along with it. And not only CI/CD pipeline, as I told you, can you see this is the Azure DevOps? This is your thing. And as per the hierarchy, did we mention the hierarchy? Can anybody tell me the hierarchy of uh, uh, Azure DevOps? I think we have discussed in our theory. What is the hierarchy? The hierarchy is always, anybody can just give me for any Azure DevOps using the CI/CD pipeline, you will have a hierarchy to follow. What is the first and the foremost, the top of the pyramid of the hierarchy? Anyone, any suggestion? Azure DevOps always starts with an organization. That is the basic structure of any Microsoft project. You have to go via organization. Okay. From the organization comes the project. So you cannot create your project without creating your organization. So this is the hierarchy. Okay. Under the project, you can create various services out of which this one is your pipeline. There can be lots of, you can create your Azure repos. What are the other things that you can do? Azure Artifactory.
So you can also use Teams.
You can also
have Teams.
The Teams services is not part of Azure DevOps. See, I'm discussing Azure DevOps. The most important part of Azure DevOps, the tool, is the CI/CD pipeline. So CI/CD pipeline, that is the most important part. Then there is the pipelines can be two types again, the build pipelines and the release pipelines. Right? We have discussed these two types of pipeline. This build is mostly for the CI and the release pipeline is mostly for the CD, the delivery and the deployment. Okay. CI is for integration, the build pipeline. Now, these are the various the sub tools under the Azure DevOps, which is CI/CD pipelines, repos. Repos is like the GitHub. Okay. It's like the GitHub. Artifactory is like the Nexus or JFrog. JFrog. These are very famous Artifactory. Now, Azure boards, you know, the Kanban or the Agile boards, the Scrum boards. There can be Agile Scrum or Kanban. Kanban is mostly related to operations. They do a lot of Agile methodology. So they follow the Kanban sort of boards, and generally the developers and the DevOps guys will use the Scrum board, mostly popular with the project managers, the boards. So these are then there is the testing. These are the various parts of Azure DevOps. We are mostly concentrated or focused on the CI/CD pipeline. Is that fine? Any question? up to this point. So we have to come down from organization. We have to first create the organization. First step is to create your organization. Within organization, you can create one project or hundreds of projects, but all within the organization. So whenever you come to this organization, these projects are under this particular organization. And each project will have multiple pipelines, either build pipelines or release pipelines, or it can have repos, artifactory, boards, and test. These are the various things. But our project will refer not to repos. We will use CI/CD pipelines. We will use the GitHub. For Artifactory, we will use, we are going to use the DevOps provided, Azure DevOps provided Artifactory. We will not use Nexus or JFrog. We will not be using the project management boards, or neither we are going to use the test for the time being. But you can integrate Selenium and so many testing utilities or tools with the test, tool of your Azure DevOps. So you can go for automation in testing. Our source of the source code, the version control, will be GitHub. We will create a link of our CI/CD pipeline to we will create a service link. Because this is an external third-party tool, or is an external tool. It is not included. What is included within Azure DevOps is the repos, but we are not going to use the repos or the repository, Azure DevOps repository. We are going to use GitHub. So CI/CD have to be linked to the GitHub through a service link. We are going to use AWS because we are going to use AWS on which we are going to use Terraform. The Terraform is another third-party tool. So the CI/CD pipeline will have another link, service link to Terraform, which again will be linked to the AWS. That is from Terraform. Terraform knows how to get the provider AWS. Then there is another part to this project is Kubernetes. The Kubernetes cluster will be created through Terraform over AWS using EKS, Elastic Kubernetes Service. So see, these are all linked. So therefore, we need to have a GitHub service link to Kubernetes as well. Are you getting me? So there are, another one. So there can be our images that can be stored in our Docker Hub. So Docker Hub, we need to have a service link as well. Any question? So this is another external tool provided by Docker. This is another external tool provided by GitHub. This is an external tool provided by HashiCorp Limited. So this is Terraform. And this is, of course, Kubernetes, which is coming from Google, but it is managed and it is service managed. It is called SaaS, software as a service. So this entire Kubernetes will be implemented over AWS as Elastic Kubernetes Service, but that will be installed through Terraform. Are you getting me? Now everything is happening over the CI/CD pipeline. This is the architecture, general architecture. Any question from your side? So we will create organization. Under organization, we will create project. Under project, we will create CI/CD pipeline. And then within the project, we will set up the service links to GitHub, Docker Hub, Terraform, Kubernetes. Is that clear?
Yes, sir.
Any question? Any question? Because see, CI means integration. We have to integrate all these external tools to work together in an automated way. AWS will be from Terraform. So Terraform will connect to AWS by how? How will AWS be connected through Terraform? You have learned AWS, you have learned Terraform. I'm assuming, but yes, of course, you will say that, Debasis, we have only gone through some internship sessions on AWS and Terraform, so we cannot learn the full thing. Yes, I agree. So the link between Terraform and AWS, so Terraform is an external tool to AWS. So what will happen? Terraform can only access AWS through, you know,
AWS.
AWS. There
CLI.
is, sorry,
API.
CLI.
API, CLI, these are fine. These are the calls. So Terraform will call AWS. So, but who will give the access? Because AWS is a very secure system, cloud system. Now Terraform wants to create some or provision some resources over AWS. I could have also used Terraform to create resources over Azure Cloud, but let's say I'm using AWS. So as a provider, I cannot directly access. So nobody, I have to get an access. Who will give me the access? You know, in AWS, you create IAM user. Identity and access management. So this user who has the access rights created over AWS, I will have the security credentials. What are the security credentials of an IAM user? Can anybody? We have discussed all these things. There are two things. In an IAM user, you will have security credentials. What are the two security credentials?
Are we talking about the access key?
Yes, the access key. The access key ID and the most important one is, so this is visible, but the security access key. This is the token. Without this token, the security tokens, Terraform will not be allowed to access AWS. Once Terraform knows this too, so it will be logging or it will be accessing through this IAM user through this access key ID and security access. Okay. All this information we have to create over this service link. That's all. I do not need to go to AWS and whatever. So I know the access key ID for this IAM user and security access key. Therefore, I will configure them when I am creating the service link. I'm going to demo that to you. In Kubernetes, I need some service link created through some also secret token, because this is hosted over EKS. EKS is the Elastic Kubernetes Service. So Terraform has created this Kubernetes cluster. This cluster will be created by Kubernetes. I'm giving you the theoretical background of the architectural overview of the entire project. This cluster will be created through some Terraform scripts, which will act on AWS on the EKS to configure the or create the Kubernetes cluster with the cluster binding role and all those stuff. Now, when I am saying to the CI/CD pipeline that please use this service link, which has been configured, so I don't have to do it again and again. So once I will create the service link with the parameters that are needed. So I will like I have given for Terraform in this service link, I have given the Terraform access key ID and the security access key. Similarly, I have to give the secret token of this cluster, EKS cluster. How I get it and all these things are knowledge inputs. I cannot explain that because you have to know Kubernetes. Okay. So unless and until we know Kubernetes, you will not be able to understand how to extract the secret token of this cluster. Once you get that, you will get to configure this service link. Any question? Now see, I'm talking of so many things that we have not discussed while we were doing the theoretical background or theory part of it, because these are practical implementation of your knowledge of CI/CD pipeline. Are you getting me? Now, any questions from your side?
Yeah, I just want to ask one small question.
Yeah, sure.
Um, since we're creating so many service links,
Yes.
question one, what does it say about the compute power when it comes to the overall architecture? And then question two, when it comes to using Docker Hub, can we run the image where it is originally located, or do we have to pull it into the Azure VM?
Yes. Okay. So what was the first question? The second question is, I will answer it. What was the first
Okay,
question I did?
okay. The first question is, I'm looking at the architecture that it's just hypothetically. Let's say we were using the entire architecture that's on the board right now.
Yeah.
What implication would that have on the compute power
Okay.
in the VM?
Very
And
good.
then
Very good.
the second question would be, is it a must that we have to pull the Docker image into the VM, or we can allow it to operate where it is, maybe like allow it to use a serverless architecture?
Okay. Yeah. So to say about the first question was with this all this technology in the background, that is the service links, which when called, okay, when you are running the pipeline, it is actually running whenever you are using a Docker Hub, it is calling the service link through an API call, isn't it? That API call will via the service link will go and fetch the image that is stored in the Docker Hub. That is the purpose, or maybe you are fetching all the source code. The source
Um,
code is all stored over there in the GitHub. Okay, you have to integrate them over the pipeline. See, why we create a service link is because everything has to be fetched over the pipeline. It should be available over the pipeline. Okay, otherwise the pipeline cannot run. So I have to get the source code. To build the source code, I need the source code. So how do I say? I will make a API call through this service link to GitHub. Now your question is whether calling all this in the runtime, the various service link, these are like calling some external APIs. You are calling APIs while it is running. So whether it is going to impact the performance, is it that? What was your first question?
yes, that's exactly what I was asking.
Yes,
In
that is
terms,
where the mastery of Azure, which is Microsoft Azure, goes in. So they have made the service link an API call. You just have to give the parameters when you configure this service links. And these parameters are so much tuned, performance tuned internally. You do not need to worry about because these are very, very efficient API calls coming from Azure, from Microsoft, so house of Microsoft. So they are must be very, very efficient. So you don't have to worry about the resources, because again, one more thing I have added or given you as an input in theory is when you run a pipeline, where it is run. That gives you the question's answer, that the resources that you are consuming, the CPU, the power, the memory, and all those things, where it is running. Your pipeline has to be, the pipeline jobs have to be running on something, and that is called some, I've given you the name, the agents. They must be run on the agents. Agents are nothing but the servers. Now the server can be from Microsoft, or the server could be from your company that is self-hosted. So there can be hosted agents. If your company does not allow for the shared Microsoft servers, then you will prepare your hosted agent with all installation of all the like the Terraform, Kubernetes, and not Kubernetes. Kubernetes you are going to implement uh, on AWS or EKS. Say any other software like Terraform has to be installed over there. Otherwise, you will not get. Like in Microsoft, using agent Microsoft is like you are using having everything that you need. So the service link, when it calls Terraform, it should it assumes that your Terraform is either on the hosted one or it is already there on the Microsoft agent server agent. Okay. So that part, these are all so much tuned that these service links are very, very efficient. I think you got the answer. So all the CPU, the memory, everything is taken care by this. These are dynamically, they can be scaled up. They can be dynamically scaled up according to your need of resources. So if you need, instead of 2 CPUs, 8 CPUs, it will be provided automatically, dynamically during the runtime. Are you getting me? So did I answer your first question?
Yes, sir. Yes, sir.
And what was I forgot. What was the next
Yeah,
question was the Docker
I
Hub,
think
right? The image.
yes, yes. The
Yes,
fact that we
yes.
need to necessarily pull it into the VM, or we can allow it to run it serverless.
Yeah, you are pulling it to the VM. VM is nothing but your hosted or Microsoft agents or the servers. So that is the virtual machine. But this is the image that your source code will be compiled or built as an image and put it into the Docker Hub. You are pulling them, either you pushing them into the Docker Hub for the timing, and then whenever you are deploying it, you are going to pull them into the pipeline over onto this particular server. So instead of going by an external agent called Docker Hub, you can use the Azure registry. There is another part of thing, Azure registry. Instead of going that, it is like a departmental store. It has everything that you need. You do not need to go. You do not need to go to GitHub. You have repos. You do not need to go to Docker Hub. You have Azure registry. Uh, what else? Okay, but since these are very, very popular, most of the images will be stored in Docker Hub very efficiently and in a very compressed format. So why to learn another part of it? So you can use your existing knowledge. So you just have to create your service link. So Docker Hub will integrate. This is part of the integration, CI. Docker Hub will integrate through the service link the image that you want. What is an image? Image is nothing but whatever your source code has been built into an image, a single image. There are hundreds of Java files. You have built it into one jar file, and then you have used the Docker file to create an image of that jar file and stored it into the Docker Hub. So you are having an image. The images are very, it is very easy to work with the image. Image is an object. So it is very, because they can be handled so efficiently as containerized images, which are very efficient. And because you have to work with the images, because why? Because you have to deploy that image. Where? Can anybody tell me? Where do you deploy it? You have to integrate it and then deploy it where? You will deploy it over onto the Kubernetes cluster. Why? Because that is the purpose. Because your cluster is like a Kubernetes cluster is a huge orchestration tool, which will help to manage the health, the working, the function of an image. And there can be thousands of such images. We are going to start Kubernetes from the next weekend. Okay, so you will get we get the concept. Right now, I understand that you do not understand Kubernetes, so leave it. Don't worry. But the thing is, it is like a orchestra. You have seen orchestra. There are so many musicians, so many musicians. There are tens and 20s of violinists. They are playing on the violin. Somebody is playing on the guitar. Somebody is playing on the congos. So many instruments are there, but they are one team. So you can think of one musician as one image. They are doing some function or one application, you can say. So the application which was supposed to play the violin is an application separate from the application which is playing the guitar. So you can think of those are microservice images, microservices. They have to be deployed over an orchestra or an orchestration called Kubernetes, because there is this architecture. Nobody will go out of sync. When you hear the Philharmony, okay, you will be mesmerized, like you are listening to Mozart or Beethoven or Jubin Mehta. Okay, you know that not a single string of music has gone out of sync. Because why? Because they are in a very well clustered system. And that is where the Kubernetes comes into function, that it will maintain synchronization of each and every pods or microservices or containers having the images. Are you getting me?
Yes, sir. Thanks, sir.
So that is why you need the images, because finally you are going to be doing the blue-green deployment or whatever deployment, canary deployment, but on the Kubernetes cluster. Because ultimately, when you are doing it in the production, you cannot manage so many number of microservices. So you need someone who can manage that part for you. Management is like updation, deletion, replacement, writing, reading, all these things are called management. And health check, security, provisioning. All these things will be done by Kubernetes. So once you are able to deploy your application over Kubernetes, your work is done. And that is what you are using the pipelines for. The pipeline has the capacity to integrate, work with so many tools. You can integrate SonarQube. What is SonarQube? One tool which you can again have a service link to SonarQube, because SonarQube is one more part, external tool. What will it do? It will, once you have built, before you build your Java code or the source code, which you have integrated from the GitHub, before you give it to building, you must check whether the code is up to the standard, that is the quality check. SonarQube will do the quality check. how good whether the code has smells, or the code has vulnerabilities, or there are security issues. It is not following the rules, standard rules. So all these things, the code has to be a quality code, and therefore it will be checked by SonarQube. You can integrate so many so many things in the pipeline. How you are doing? You have to create your pipeline. Any other question, Ernst or someone else? Did I answer all your questions?
Yes, sir. Yes, sir. Thank you.
Very good. So can I erase this diagram? Let us go into the main part. Okay. So now you see, I have created Debasis Kalkey. These two are my organization. You can create your new organization. You cannot proceed to create a project without being into any project, into an organization. So whenever you start new, fresh, there won't be any organization, right? So what you do is first create, there will be a default, or the username that you have created, the account is by default an organization, but that is a default organization. You want to create a new organization, you can use the new organization. Without organization, you will not be able to proceed. So I have already created my organization. And under this organization, I have few projects. Okay, so let me go to this project. So on the left hand side, what you see is there are various navigation. On the navigation toolbar, you will see so many options, out of which you can now directly see that there is one, as I told you, there is the Azure board. Azure board. Just now we have seen Azure boards, isn't it? This one. This is one part of Azure DevOps. Azure boards. So you can use a Kanban board or that is exactly what you do as a project manager or a servant leader or a scrum master when you are managing a project, an agile project. Okay, I'm not going to that part. You can define the sprints, the backlogs, the board, the queries, the delivery plans, so many things. That is a different topic, but it is included within the Azure DevOps. You come to repos. A repos is like you would like to have a repository within the Azure DevOps. You do not need to go to GitHub. Are you getting me? So you can clone to your computer. So you have something like exactly similar to your GitHub repository, but you are creating your own repository within Azure DevOps. Or you can bring in all a repository from outside. Let's say from GitHub for Bitbucket. Okay, it's up to you to use. So you can use the files, you can create the files, you can import the files, you can commit, you can push, you can create the branches, and exactly what you could have done in GitHub, you can do over repos. Is that clear? Okay. These are the boards. Now, the main thing we will do, like artifacts. This is also a part of, like I said, the artifactory, Azure artifacts. So this is a place where you can store your artifacts. Artifacts are produced after you have done the build. Okay. And the main thing is your pipelines. In your organization, you have to set up, if you, by default, the build pipelines are already there for you to start with. But you can make your organization, there is a settings within the organization with which you can create, or you can say that I want another type of pipeline called the release pipeline. Generally, Azure DevOps is why it is so popular, other than Jenkins, other than GitLab, is because it is having the release pipeline. So most of your manual part that you do, that you go to your managers to get an approval and all these things, that you can build through a pipeline, automated pipeline called release pipeline. So before you deploy it, you will have all those release. You can configure your release pipeline. You can publish and release it for deployment. Okay, with permissions or approvals at various exit gates. This is not, it is impossible to cover in just a one Kubernetes session, Azure DevOps session. We take around 6 to 7 sessions of 2.5 hours to cover, to learn Azure DevOps. And then we do a project along with Azure DevOps and Kubernetes. And as I was explaining, that takes around 5 sessions. So it is not simple. It is not simple, but it's very challenging and very interesting. Because once you learn the pipelines, you have learned the heart of DevOps. Okay. Because pipelines is the only part which where you will see the culmination of your entire learning of DevOps, where you will put in all the tools that you have learned so far, integrate them and see them working together as a well-oiled machine. Are you getting me? So learning and the automation is dependent on how nicely you can build your pipelines. Now, I'm going to my build pipeline. OK. So there are 2 pipelines. These are called recent pipe. These are the 2 pipelines that I have created for the project. OK, or you can just simply create a new pipeline. Whenever you will go to create a new pipeline, first question that will it ask, the pipeline cannot work without integrating your source code. First step. So it is naturally asking, where is your code? Can you see the questions? Where is your code? I will say, if you have your code all stored over the Azure repos git, that is, which is given by your Azure DevOps. So you will select this. So you know your source code is all stored over here. If it is in the bit bucket, if it is in the GitHub, or it is in Subversion or any other Git, you mention that. You will say your source code is in the GitHub. So let's say I have my source code in this GitHub. So this is my GitHub. This is the repository on the GitHub. OK, so all my source code has been stored over here. OK, so here I am mentioning what do I do? I will select GitHub. You see, I want to connect to GitHub. Then it comes to the selection part. That way you can, I will say that I want to have this particular diversity under this is the account and DSA 43 Azure, whatever. This is the GitHub repository. So you are creating a link between your pipeline. That this is called the service link. This is one of the links according to this diagram. You are linking your pipeline to the GitHub such that anytime any changes of the source code happening over the GitHub, you can trigger the pipeline. Are you getting me?
Yes,
Any
sir.
questions?
Yes, sir.
It is very interesting. Actually, we have to learn it properly. So I'm not going to the details of, I'm not going to see the list. So the link will be created. It will be selected, then you will configure, and then you can review it that, yeah, your link is working. You will test it. Clear? So that is how I will show you the things. So I will go back to my pipelines. So as I said, you can create your new pipeline. It will always, any pipeline has to be connected to your repository, whether it's a Azure repos or GitHub or Bitbucket or Subversion, whatever it is. Is that part clear? After that, see, I have already, so that link has already been created. So I can check that in my project settings. This is my project. This is my project that I have created under my organization, Debasis Kalkey. Project has been created. And when I was creating the project, I had mentioned that the project is a private project. This should not be available to any external user. So I'm building a privacy and a security. So anyway, I'm going to the project settings. See, I am clicking on this part. There are lots of things, but what I was interested is a service connection. I'm going to my service connection. This is a very important part. So in this project, I have 4 service connections. As I told you, I will have a service connection or a service link for my Kubernetes. I will have a service link for my Terraform. I will have a service link for my GitHub, and I will have a service link or a service connection for my Docker Hub. So how many? 1, 2, 3, 4. So can you see? 1, 2, 3, 4. So first thing, I have already learned about this one. I will just. So I have just now seen that when I was creating a new pipeline, I have already created or connected or created a service link to my GitHub. This is a GitHub, and this is the symbol or the logo of GitHub. And this Debasis Gym is the account. I have given a name. I can give it any name. I just prefer to give it Debasis Gym, my account name. Clear? So you have seen, you can click on this, but you will see that this is a GitHub. The service connection type is GitHub and the creator. So you can see the user's history. I will go back. Coming to Terraform. Let us do the Terraform. Okay, I will click this. So this is just a name of the service connection. So the service connection type is AWS for Terraform, because Terraform is going to work on AWS, not on Azure. So I have used Terraform service link, but that Terraform is going to work on AWS. So if I go to edit, I'm just showing you, I've already done it. So as I told you, my Terraform is always going to call an API call with AWS through what? As an IAM user. So AWS will not allow the Terraform to connect to it unless and until I have given the correct access key ID and the security access key, the token. Clear? So this is my access key, and I cannot see my security access. That is the secret. It is like a password. Will you see on the screen the password? No. You have to give it, and nobody will be able to. Yes, this is fine. Even if you know this one, doesn't matter. Unless and until you know this, you will not be able to connect to my IAM account or anybody's AWS IAM account. So the region is whatever you can give the region, which region or where you want to create your AWS resource. with the Terraform. So I want to create my resource in US East 1. US East 1 is Ohio, I think. Or no, sorry, North Virginia. And I have given a name to the service connection as AWS for Terraform. You can give it any name. And you grant access permission to all pipelines. Whatever pipelines you create under this project, you give an access permission and you save it. So you have created, see how simple it is. Did you need to know much anything about it? That is the beauty of knowledge, that you know that I need to create a service link. If I do not create a service link, however good I am in Terraform or in AWS, I will not be able to connect my pipeline to work with Terraform over AWS. Is that part clear? Any questions?
Should the region match up with the one that you have provisioned in on your AWS cloud?
A good question. So yes, because I'm creating my Terraform. Sorry, Terraform is going to create something, right? Terraform is a provisioning tool. So Terraform is creating what? Terraform in my project, Terraform is creating the Kubernetes cluster. Are you getting me? The Kubernetes cluster. Now this cluster will be created in a particular region, not in all regions. And that region is my North Virginia, US East 1. Is that clear? You could have given anything. You could have given, say, AP Southeast 1, which is nothing but Singapore. Or you could have given AP South 1, which is Mumbai. But here I am going to create over US East 1. US East 1. So that's what I have done. Because my cluster is going to be created. So if you go and check that I want to create an elastic Kubernetes service, right? Now, I'm not going to do it manually. My Terraform script, Terraform will do it and create a Kubernetes cluster over Amazon Elastic Kubernetes Service. I have not created anything. Okay, if you are going to create a cluster, it will ask now here the region is Singapore. So that is what I'm saying, that I'm going to create it in North Virginia in the United States under which is US East 1. Is that clear? So this is one resource that I'm going to create through Terraform or on AWS in this particular region. Okay. When you run it, you will create it. Now, what happens to, oh, sorry. So that is, I have created one service link with all those parameters. Coming back. Coming back to, first of all, let us see about the Docker Hub. So this is a Docker registry. It is the Docker. You can see the symbol Docker. So I am creating on my over my pipeline. I am creating a service link to link it to Docker Hub. How? So I can go to edit, and I'm saying that the registry type is not Azure Container Registry. As I told you, there is the Azure registry, container registry. If you want to use it within Azure DevOps, that's fine. Okay, but I'm very comfortable with Docker Hub. So I'm saying I want to use Docker Hub registry type, not the Azure container registry. And I have a Docker ID. So if I go to Docker Hub, this is my Docker ID, which is my account. Debasis P1234567 8. That is exactly what I have given over here. Okay, and I have a Docker password, and this is the email for verification. So I can verify whether the service connection is fine. And I'm giving it a name, service connection name, that's all. And then you can verify and save that your connection is working and grant access permission to all the pipelines. It's very simple. The inherent architecture is complicated, but you are working on a very higher level. You are not concerned how Azure manages, Azure DevOps manages all these things internally. How the API call, like your first question was, how fast it will be, whether it will be resource intensive, it will take a lot of memory, it will take a lot of CPU. That is an internal consideration. How they manage the resources is internal thing to, and you can bet they are the masters. Azure, Microsoft is the giant. So you can rest assured that the performance will not get degraded. It is very, very fast, in fact. So you go back to your service connections. The last thing is your, I've given it a name as AWS Kubernetes Cluster Service Connection. So I want to connect to the Kubernetes cluster that was created on over AWS over through some service connection, which is connecting your pipeline to that particular cluster or service. Go into that. So I have given this service connection. You want to create a new service connection. OK, you are wondering how I have created. Nothing. It's very simple. You will go to this. So what you want a Kubernetes connection over AWS. So Kubernetes, you see, I've got that. So then you say next. OK, and you will not go for Azure subscription. You can go with the, yeah, I will go for the Azure subscription. Sorry, I will go with the service account, because service account is, because I know each, this is not, I have not created my Kubernetes cluster on Azure. So how can I use a Azure subscription? Right? I am going to use a service account, and that service account has been created over AWS because my Kubernetes cluster has been created by Terraform on where? On AWS. So I will go to service account, and as I told you, so this you will get the server URL. How do you get the server URL? You have to know about Kubernetes. So from the cluster, I will use kubectl command. Kubectl we will learn in our Kubernetes sessions, which we are going to learn from the next weekend. OK, so don't worry. This might be a term not very familiar to you now right now, but don't worry. So with the help of this command, the CLI command, I can query my cluster to get the where is my cluster, what is the server. So this is one of they have given you a help how to go about use this command to get your cluster server information. So I could have shown you if I have a cluster how to go and check that, but this I'm doing directly with the help of the kubectl command, and therefore I will get this server URL. Server URL is where you have to mention to your pipeline that where is your cluster, where is your Kubernetes cluster. So you are giving a particular server on which, that is the AWS server on which the Kubernetes cluster has been created. You can go for serverless, or you have created onto some physical server of AWS. That is what you are going to mention it after you have extracted the value, the URL. And then this is the secret. Like when you are connecting Terraform to AWS, you have given access key and the secret access key. Similarly here, by running the kubectl command, you will get the secret value. Secret is the secret token. It is an SSL token, service token, the security token. Okay, so that you will put over here. It is giving you some help how to go about it. Then you give a service connection name, whatever my service connection name is, AWS Kubernetes Cluster Service Connection. This description is optional. You say click on it and then save it. As simple as that. Are you getting me? So I have got my, if you edit it, you will see this is my server on which the Kubernetes, cluster has been created. Okay. This is the secret. You cannot see it. This is the secret token value. This is the name of the service connection. And you have granted permission to all the pipelines and you have saved it. Any question on this? Service connections are the first and foremost important activity that you need to do when you do it. Then you go back to your pipelines. Okay, I have two pipelines. I will just in a nutshell, I will let you know what is how things are done over here. So I will click on this. This is the cluster. This is a pipeline. Like I have created, starting with a new pipeline. I have created a pipeline, and actually my pipeline and all the stuff is there over. As I told you, this is my source code, and I have kept my pipeline. See, this is 01 AWS Kubernetes cluster IaaC pipeline.yaml. Exactly 01 AWS Kubernetes cluster IaaC pipeline. So what I am writing over here is available over here. So basically, this is the place where I'm storing my code. After all, this pipeline is a code. I'm writing is an YAML file. Are you getting me? Yeah, some question from your side. Somebody has raised some hand. Yeah. Ima, you have a question? Yeah, tell me, please go ahead. You had a question or can we proceed? So if I click over here, you will see that I have written exactly, I was telling you how to write a YAML file. This is nothing but a key value pair. So this pipeline will be triggered. Okay, let me show you from there because there is a link. So I will show you from here, from the Azure DevOps. So I will click on this, on the pipeline, which I have already created because there is no scope of writing it again. I will edit it, go to the edit. There are few runs, few changes over this pipeline that I have done. Okay, edit. So where it is getting this code from? Immediately it is going and fetching it from Debasis Jib. This is the account. This is the GitHub account. This is the project, a repository, you can say DSA 43 Azure, whatever. And this is the pipeline. So exactly this is, it has downloaded, or what you know, it is just showing you over the editor, the same code. Now, oh, sorry. Now I will. So let me, in the task section, I will just hide it so that you can see the, can you see the screen?
Yes,
So
sir.
you are,
Yes, sir.
yes, you are inside the pipeline, a YAML file. So what you are doing, you are coding the pipeline. This is called pipeline as a code, or PAAC. This, when you run it, save and run it, is you are running your pipeline. So when there is some changes on the master branch, it will trigger your pipeline. That is what you say in the beginning. And you say pull. Pull means what is your agent pull? And you say my VM image is nothing but Ubuntu. What is this VM image? This is your Microsoft hosted pull VM image. That means you are saying VM means virtual machine. So you are asking Microsoft to produce or give a server from its hosted pool. So here I am not using my hosted agent. For my convenience, I am using a virtual machine given to me by Microsoft from its pool to run my pipeline, and that virtual machine is running on Ubuntu 22.04. Ubuntu, Ubuntu is a operating system. So I have a virtual machine provided by Microsoft as an agent, which is having Ubuntu as the operating system. I do not have to install anything. It is as simple as that. And in this server, I will get all the necessary hundreds and hundreds of softwares that can be integrated into your pipeline. You don't have to worry. So there are so many tasks, the huge list of tasks. Everything is inbuilt for you. That is why it is so popular. You do not need to code. You do not need to write Python code or Python script or Groovy script, where Jenkins is very finicky about. You have to write Groovy scripts. You have to know Groovy. But here, you just have to know how to use these tasks. The rest, everything is done for you. Internally, those tasks will be converted into shell script. And also here you can write, see, here I have written script in the steps. Steps means your tasks. Script, echo, hello, welcome to Azure DevOps Capstone project. So you know echo command is it's an inline shell script command. So it will be displayed on the job log. And you say display name. This is the first task of the project. Now, can anybody tell me, did I mention stages? Did I mention jobs? Did I mention why did I not mention any stage or jobs? Why directly I came into steps? Because I know the hierarchy. The hierarchy is you say the stage, then the jobs, within the jobs you have steps. So first is the organization, the project. Under project you have the stages. So under the project you have the pipelines. Under the pipelines you have the stages. Under stages you have jobs. Under jobs you have steps. Steps is where you take the action, the task. I have written a shell script, echo. So this will be printed on the screen. And I'm saying the display name is the name of the task. First task of the project. So all this thing will be displayed on the job log. And first task that you are saying Terraform. You want to do what is the first thing that you want to do? Oh, okay. Nobody has told me why we are not having anything called stages or jobs. Can anybody attempt? Try. Just guess. Anyone? Just a guess.
Isn't it because this is AWS, so it's a third party, so it's not happening inside Azure?
No, no. It is Azure DevOps. You are writing within Azure. We are no way connected to AWS. AWS we will connect through Terraform, but through the pipeline, through the service link. But here we are writing the YAML code directly on the Azure DevOps pipeline. This is the pipeline script. You'll see the full name is 01 AWS Kubernetes cluster IAC pipeline.yaml. YAML is the script, the code. You're writing it directly on the Azure DevOps under the project when you are creating new pipeline. I have already created the pipeline, but I'm just showing you. So the question was, why didn't you mention the stages and the jobs? Why you directly started with the steps? So is it a syntax error? Will it allow? It will allow. This means, can I attempt the answer, or somebody will try to? Somebody will try to attempt this question. Anyone? Because I have no need of any stages or no need of any jobs. The stages and the jobs come only into picture when there are multiple stages, and within a stage there can be one job or multiple job. Here I have just the step, one step. The rest is, I mean, there is only one job. There is only one job. So I do not need to mention if there is only one job, that means it is only one stage. So I do not need to mention the stage or the job. I can directly start with the task. This means I have only one stage and one job in the entire pipeline script. Rest, everything is taken care by the task, the inbuilt task. Is that clear? Why there are no stages and no jobs? Because there is no need for any stage or job, because there is only one stage and one job. The job is to create your Terraform. Terraform will need to access, first of all, it will need to access the AWS. And next, after it has gotten access to AWS, it will now create the Kubernetes cluster. So for that, I do not need to have any stage. It will just, I will use a task. Now, first task is Terraform init. Init is the command. If anybody knows Terraform, you know there is an initialization command of Terraform called Terraform init. We have discussed that in our Terraform session. Okay, so to init has a lot of things to do. So I will first do the initialization. So initialization does the Terraform backend where the states will be saved. Okay, and it needs to execute the Terraform script. Now, where is the Terraform script? Now, the Terraform script is under configuration, under IAC, under AWS, infrastructure as a code. Under that, these are the various folders that I have created and under Kubernetes, because my main task is to execute the main.tf. That's all. And this is the main.tf. Main.tf is the Terraform file. So here you are using a backend, and the backend is the S3 bucket. Okay, I'm storing it in the entire Terraform bucket or the information, the state information under, not locally, but into the bucket. These are all very fantastic ideas. This is why DevOps is so popular with all the companies nowadays. You are using cloud, you are using bucket, you are storing your secret information within the bucket, and all this stuff. And who is doing that? Terraform is doing that. So it is initializing the bucket. And see, you have given just a dummy name and the key and the region. Now all this will be overridden during the build. Build means when your pipeline will execute this task, execute this Terraform init task. So during the build, actually it will know which one is the bucket. So the bucket name is this one. So I have already created a bucket by this name in a particular region. All these things have been defined over here. Sorry. So the region will be under US East 1. So the bucket will be created in this particular, that is North Virginia, and the bucket by default it is having some name, but this will be overridden. In the object orientation, oops, this is called overriding of a function during the runtime, dynamic overriding. It is also called polymorphism. If somebody knows C++ or Java, they will know what is object-oriented programming and what is polymorphism, overriding, function overriding, and all the stuff. So this is just a static holder. But so whenever you are executing this Terraform script, main.tf, it will pick up the parameters or values from these values. So the bucket name will be like this. So it will override the name my bucket. The actual bucket name comes from when you are running the pipeline through this task. Okay, so you can go into that task, but let me. So it is very simple. I will show you. So if you are going to use any Terraform task, you just say Terraform. Now I want to execute some Terraform commands. So what is my command? Terraform command is init, Terraform init. So you select this and you say what is the provider? What is your provider? Your provider is AWS. What is the command that you want to do? You do not want to apply, you do not want to show, you do not want to use plan, validate. These are all output, destroy, custom. I want to use Terraform init. So you just select that init. Configuration directory. Now, where is your Terraform file, that main.tf? Don't you have to mention this one? The path? This one? Configuration, under configuration, you have IAC, AWS, Kubernetes, and then the main.tf. So you do not have to mention main.tf. So what you do, you say system default. Now this is, as I told you, this is the pipeline global variable, system.default working directory. So wherever you are, this is there is some value to it. So your system default working directory is this Debasis GIF, this one. So it will directly go to this particular default directory, working directory, this one. So basically it is going to this one. Yeah, so it is basically going to Debasis GIF, this one. This is the default system working directory, sorry. And after that, you have to come to where? You have to come to configuration IAC AWS Kubernetes, isn't it? Because your main.tf is under here. So you have to come to your configuration directory, your IAC, your AWS, and Kubernetes, because there you will find that main.tf. It is only going to execute something which is ending with tf. So there is only one file called main.tf. So this is the file that it is going to execute. Am I see these things I have already done, but while in pipeline, I do not need to redo it. I just have to call it over the service link. So that is the service link. That is the task you are doing. And what is the task name? Display name is Terraform init. You can give it anything. This is just a name. And then you say this is, so you will have to give what? Configuration IAC, then what was that? IAC, after that AWS. So you will say AWS, and then you will say Kubernetes. You do not need to mention any Terraform file. That is the configuration directory. You can give any additional commands. Okay, but I do not have any additional commands. So what is your Amazon Web Service connection? You will select. Remember, we have defined this service link, AWS for Terraform. You will select this. Then now my bucket is not there, so I will not be able to, because I'm not going to, it will not be able to load because the bucket is, I have removed the bucket. So it will not find. Otherwise, it will pick up the bucket name from the default region. So that region, so it will, so what was the default region? What was the region that I mentioned in my service link for that AWS for Terraform? The region was US East 1.
US East.
Yes. So under US East 1, under your IAM user, whichever bucket you have created will be listed. Now the bucket is not there, therefore it is not being able to list it. No results found. Otherwise you will find it. Then you will say the key. What is the key? The path to the state file. Now there is Amazon bucket. Now where did you mention the key? The key is nothing but AWS key that you have defined within the pipeline script. Within the Terraform script. Yeah. So I have said this is the Terraform backend state Kalkey 123. That is, while I've created the bucket, I've mentioned the backend state, whatever the key is for that bucket. Okay, and you are just mentioning that part, that key over here. And once you have done that, you will say add. And once you have added it, it will be over there. So it is very simple. You have to just do the project. You have to do the project. So you see what was the output. Now, whatever you do, you place the cursor over here and go for the cursor over here and go for the task. Say you want to have the Terraform task. So whatever you do over here, and when you say add, the entire thing, like it has been listed here, the task name, display name, everything will be. So display name, you will do it, and all the inputs will be done. Okay. So the inputs are provider is AWS. The command is init. The working directory is this thing. I will hide this. The working directory is this configuration IAC, AWS, Kubernetes, and the system default working directory. You have given the backend service, the service link AWS for Terraform. What is the bucket name? The bucket name is over here. You are giving the bucket name because this is the physical name of the bucket that you have already created on AWS. I know it is a bit difficult for you to understand if you are not having a knowledge on Terraform or Kubernetes or AWS. I hope we have covered AWS, we have covered Terraform, we have covered the CI/CD pipeline in quite details. Now today's demonstration, we have not covered Kubernetes. We will do it from the next weekend. Okay. Similarly, now another command you want similar to init. I want to do the apply because I want to apply that particular. This is for the init, and I want to do the same thing for my for applying, that is creating the Kubernetes cluster. So you are basically applying that file main.tf. So what is your provider? AWS. What is your command? Apply. Terraform apply. What is your working directory? Where basically where are you going to get that Terraform command? The command file, the configuration file. So this is your path. And what is your service name? AWS for Terraform. Another one. So this will be coming to the last. This I have added at the very end because I want to destroy the cluster. So once you have done this, when you run, suppose you do not have this. You do not have this. And when you run it, what will happen? It will run the pipeline. So what will happen? It will use this VM image. It will echo the first task, display the task, and it will Terraform init. It will do the Terraform apply. So once it applies, it will create the cluster. I mean the Kubernetes cluster. Any questions? So how simple it has become, right? So now you may ask Debashish, you are saying all these things, but can you show us the job? By default, the job name is job. So I will just click on this. Okay, and these are the various stages of the job, the various steps. So it will initialize the job. It will check out. Check out means it will get the source code from where? From the master branch of the GitHub. After that, so you can go there and you will see these are the various stages, the various steps. It is using the Git. It is connecting to the GitHub and using the master branch to pull in. Sorry, to pull in all the configuration, all the source code. Okay, it is giving a job description. This is the log. What happened? So it has gone to this particular. See, can you see Debasis Jiv and Azure DevOps Capstone project into this repository, and it has fetched. So finishing the checkout has been finished. So it has got all the source code from GitHub into where? Can anybody tell me where it has downloaded it or fetched it, pulled it? Into the default repository, into the default, system working directory, system.default working directory. Under that, There it will now go for. So the first task of the project, because that was the name of the task. So hello, welcome to Azure DevOps Capstone project. First task of the project done. Then it will go to the Terraform init step by step, starting Terraform init. You see, initializing the backend. The backend was stored where? In the AWS S3 bucket. And it is creating the cluster. Not creating the cluster, it has done the Terraform init. Okay, the init, the cloud init and all those stuff. Initializing provider plugins. It works through the plugins. You know that in Terraform. Terraform has successfully been initialized. It has finished Terraform init. Then it will come to the next task, which was, that task that you have done for apply. Now it is executing Terraform command, that is the Terraform apply. Isn't it nice? Everything has been done. So author is Microsoft Corporation. So it is using that particular script, Terraform script, main.tf, which it has downloaded or pulled. And it is now creating the cluster, Kalkey cluster. So this is the command, Terraform apply auto approve. Now you will ask me, did you install Terraform anywhere? How it is possible that Terraform apply will not work if there is no Terraform? But then you can ask me, Debasis, how it is possible that Terraform is working? Can anybody answer me that question?
I think it happened when in the Terraform init stage.
Yes, Terraform init stage, but Terraform init also needs Terraform as an application software. I did not install Terraform anywhere in my project. Did I install anywhere? I simply created the service link. That's okay. But where is Terraform? How will this Terraform apply work if there was no Terraform installed? Terraform is a software from HashiCorp. Did I install Terraform anywhere? In our job ready program, we learned Terraform by installing Terraform, then on AWS EC2 instance, and then we started learning Terraform. But here we did not install Terraform. We are running that Terraform script. But that script can only work if there is Terraform available somewhere. Where is Terraform now? Now my Terraform is already available. Remember, we are running this job or this pipeline. Who is running this pipeline? Can anybody tell me? Who is running this pipeline? There is the answer to this question. There is a server given by Microsoft because I am using a Microsoft agent, VM, from the VM pool, VM image. The VM image is Ubuntu 22.04. There in that server, Terraform is already installed by Microsoft. That server has all you need. I have not used configured or my hosted server with Terraform install in it. No, I have not. I do not have any server. I'm doing from my home. I'm doing as a freelancer. I do not have any company. If I'm working in a company will ask me to, yes, use this server to make it a self-hosted agent for this thing. But since I do not have any server, so what I do, I use the pool as my VM image from Microsoft. That's all Microsoft is providing. Microsoft is given me a server to run my pipeline, and where in that server Terraform is already installed. That's why it is possible to run this. If you run it in your hosted server and you did not install Terraform over there, this command will fail. It will not be able to run this Terraform apply. Are you getting me? Because the Terraform is already available in an installed state in the Microsoft provided agent or a server, you are being able to execute Terraform. So Terraform now applies that particular main.tf where it installs that cluster. A very fantastic idea. So it is using the Kubernetes cluster. So it is creating a resource called Kubernetes cluster role binding. Kubernetes secret. It is installing a resource called Kubernetes secret, a service token. Okay. And so Terraform apply has done. So it has created your cluster, Kubernetes cluster. So my pipeline, the purpose of my pipeline is done. So post job checkout, and you have done some checks over here. And there is a finalize the job. So entire job by the default name as job. See, I have not defined jobs under that job because there is a single job. By default, the single job name is capital JOB. Any questions up to this? Now my pipeline has been, my cluster has been deployed and created by Terraform. Now coming to the second part, I have created two pipelines so that they are segregated. I will edit this. You will see how simple it is. Now it is the main part of where I will publish, build and publish. See, it is, we have not done anything with our build. Now it is the most important part that we are building it. So I'm not going to the much details because more or less our time is up. I will just say that this is how your pipeline works with the various other tools. You say trigger master, resources, repo self. So all the repository that you are creating is on the Microsoft agent, that is self. Here in this server, you are creating the repository and all those wherever you will publish for building. So variables, you are using this build and the build ID. So this is a variable that you are defining on the pipeline. So it's a global variable. You can use this build ID. So build ID is like the release version of your build. Okay. So you run it, the ID will change. So there's another release. So that way, till you are happy with your build, you will keep on running this second pipeline. Okay, because there can be a possibility the build can fail. So what now I am giving stages, you see stages, and the stage name is build. And the display name, the display of this particular is a build image. You can give any name. The jobs, I have a job by the name build. See, stage, under stage comes one stage. So under stages come the jobs. Under jobs come job. What is the job? The job is build. It's the name of the job. So display name is build. This is the job name. This is just the display name. That the display name will come as on the job log. Pull. So again, I am using the VM image Ubuntu 2022.04, and we start the steps. Similarly, now I want to build my source code, the hundreds of Java file into one Docker image. How do I do that? I will use something called Docker. Okay, Docker. And you see, I will use this particular task. Build or push Docker images, log in or log out, whatever. Start or stop. So all the Docker activity, you can do it with this particular thing. So I have done that. This is the task. So again, as we have done it, we have seen it for Terraform. You will, because you know there was a service link between Docker and Docker repository. So the pipeline and the Docker repository. You will use that service link. And what is the service link? DSA Docker Hub. So this is the container registry. This is a Docker Hub by the service link. And what is the repository name? Debasis P. This is my account. And this is the image. If I go to my Docker Hub, I will see that the currency exchange DevOps DSA 43. This is my microservice application that I have done. Sorry. So you see currency exchange DevOps. Oh, sorry. So I will Docker Hub. There is currency exchange DevOps. This is the image. This was a Java microservice application. And this entire source code is available over SRC. So this is my Java programs. Exchange controller, currency exchange. So it is like you are converting dollar to Indian rupees, INR, or you are converting INR to euros. So this is a simple application. It's not very complicated, but it's a microservice application. I can have multiple such microservice. So what I'm doing, I'm creating each of this application into one image. And that is the service that we are doing over here. We are using this particular image and building and pushing it through the use of a Docker file. So now I have a Docker file as well. And you know Docker, and this is the Docker file, which will compile it or build it into a jar file. You see, this is a jar file. The jar file means it is compiled with Maven. So it is done. There are lots of things, my friends. There are lots of things to learn. It is not possible. It is not within the scope of this internship session to be able to deliver each and everything. So this is what I'm saying. This is a file, a manifest file of Docker through which you can build your image out of your application. So this is the jar. Jar is Java application archive or archive, Java archive file. So you are building a Java image into a Docker image. Sorry. So once that Docker image has been done or compiled through Docker file, if the compilation is successful, so your build, you will push it. Build and push. This is the command. So this, if I show you, are you there? How many of you are there? Okay, fine. So I'm just concluding it. So just if I say tasks, Docker, and you say Docker, and so you will say Docker Hub, DSA Docker Hub, that is your, and the container repository. So you give the repository, that is the entire thing over here. Okay, and what is the command? The command is, there are several other commands like build, push, login, logout, start, stop. These are Docker push, Docker pull, Docker build. These are various Docker commands, out of which build and push is you are building and pushing it into the Docker Hub. You are building an image from the Docker file and pushing it. And then you are mentioning the Docker file. So this star means your Docker file is available in the root folder. So where is your Docker file? It is under the root folder. See, this is the repository, and in the root of the repository, there is the Docker file. That's all. See how simple. Once you know, this becomes simple. And simply you say add. You give a tag of this, you give a build number of that build. So if you go there and you will see there is a build number. There is a build number. 118, 116, 115, 96, 68. These are all build numbers. The number of times I have built. So, okay. As simple as that. You say add, And therefore, this entire thing will come as a code, as a pipeline code. So again, now you will copy these files to the Artifactory, because those are artifacts. After the build, you produce the artifacts. You publish the artifacts, and then what you do, you have to copy them from where? From the default working directory to the target factory, to target folder. Target folder is the build, which is the environment system environment variable, and the artifact staging directory. Don't worry about what is the artifact staging directory. It is handled by Azure DevOps. Okay, it is the Artifactory. This is the Artifactory, Azure Artifactory. So it will pull those images or the artifacts and put it where? In a particular, in a very structured format. If I had time, I could have shown you, but there is no time enough. So it will be very nice. That means whenever you publish it from the artifact staging directory, you publish it for as a container into. So there is another task called publish build artifacts. Okay, so you will say publish build artifacts. So this is the task you want to publish. You give it a name. So I have given it a name as artifact name as manifests. Okay, I have given the, instead of drop, I have given, but drop is the default name. You can give it whatever you want. And the publish location, where do I want to put it? Is the public location is the I have to give, my build is not yet done. So path to publish, because I have not yet run it, and therefore I will not be able to give it a location name. So publish location is the container. Here, Azure pipelines. So this container is when you have a Docker build. I have not built any Docker image. So therefore, otherwise it will be always a container. You can give it any name as such. So basically, it is a published location is not Azure pipelines. It is somewhere as a Docker container. Okay, so it will be available as manifests from the artifact staging directory and using the publish build artifact. So it will publish the artifact. Why you publish the artifact? Because it will be the next stage is your deploy. The deploy will pick up a task, download pipeline artifact. So all the artifacts that has been published into as container will be downloaded. And once it is downloaded into the artifacts directory, from here, Kubernetes manifest. So there is another task called Kubernetes, where you will be able to finally run the Kubernetes file. Where is the Kubernetes file? The Kubernetes file is, let me close this, is the deployment.yaml. So you do not know Kubernetes, so I'm not going to go into this, but basically try to remember, try to understand that this is, oh, sorry. So this will be under configuration. Under configuration, you will say under Kubernetes. There is a file called deployment.yaml. This we will discuss in our Kubernetes session. It will basically deploy those images inside a container called pod onto the Kubernetes orchestration. So for that, what you have done, you have used a inbuilt task called Kubernetes manifest. So you say look for Kubernetes deploy to Kubernetes. So this is the action is deploy. This is the task, deploy to Kubernetes. So you're deploying the images that you have stored as an artifact in the artifactory, and you have downloaded it, and now you are pushing it or deploying it to the Kubernetes. So this is the entire project, but I know 70% of it is not known to you, or it will be difficult for you to understand at this stage. Why? Because you are not aware of the whole thing. But it's very interesting. This is just for our, you know, this is just for our understanding of why we need to learn. This is not simple, but it is not also complicated once you know how to do it. That's make you different from the crowd, because these are the latest technology. These are state of art technology. This is where you can do automation. You can do a lot of things which a company is looking for in you as a DevOps guy. Okay, so today we end here. I think we have taken a lot of time. So anyway, I will stop the recording and stop sharing. Thank you. So tomorrow, sorry, not tomorrow, on the next weekend, we will start with Kubernetes. Thank you. Thank you very much. It is complicated, as I say, but it is not beyond comprehension. Once you know it correctly in the best way possible. And that is our endeavor, to give you the correct knowledge in a correct way and very interesting way. Okay. So thank you very much. We will end the session over here. Thanks for your time, your patience. I appreciate that a lot. On a Saturday evening or a afternoon or a morning. Thank you.
Take care, sir.
Thank you. Thank you. Yeah, I will. Thank you. Thank you, Ernst.